Okay, good afternoon, everybody. Welcome to today's webinar. Thank you very much for joining us today. As you can see, we are going to be talking about product design and the supply chain in the current coronavirus world that we find ourselves in. We essentially are, in particular, we're going to be investigating how we might need to think differently in this new world. My name is Andy Webber. I am going to be your moderator for today's session. I just want to briefly introduce Paul and Harvey in a moment, but before I do, just direct you to the chat box. Many of you have found it already. Thank you very much for your introductions. It's nice to see we have a group with us from all over the world. Always nice to see some international interaction with these sessions. If you do have any technical problems, please do type a message into the chat box. And equally, we will be having a question session at the end, around 15 minutes of questions at the end. So if you do have questions, again, type them into the chat box and we will address them in the questioning session at the end. I'm not going to talk too much further. I would like to introduce you to Paul and Harvey. This is us today. My name is Andy Webber, as I said. I am a principal consultant with the institution. But without further ado, I would like to hand you over to Paul and Harvey to introduce themselves.
Hi, good afternoon, everybody, or good morning, depending on where you are. My background is a combination of product and systems development, primarily in the world of IT and telecommunications, but then more laterally in supply chain management. I primarily focus now on helping organizations get their operating models fit for purpose, but I have extensive and I guess sometimes I reflect quite painful experiences of working in many different kinds of service supply chains, including reverse logistics and repair operations. Harvey.
Thank you, Paul. And Harvey, how about you?
Okay, I was chatting away, forgetting I hadn't unmuted my microphone. Apologies, everyone. So I'm Harvey. I'm an engineer by training. I spent over 25 years in the car industry with Rover Group and with BMW, and started off my life in research, then moved into product development, and in the later stages of my career there, moved into production controls, supply chain management, and strategic roles before leaving BMW Group from the Mini Factory in Oxford in 2004 to work as an independent trainer and consultant, using a lot of that breadth of knowledge I gained in the car industry to work with manufacturing and product development environments in a wide range of client companies. And as part of that, I'm part of the associate trainer team at the IMechE in this subject area. Hello. Right. Charlotte's just noticed that I'd somehow still got my microphone muted. But I think I'm okay now. So I don't know how much of that you missed. Sorry.
Hi, Harvey. We heard the full introduction. It was just when you changed the slide that you muted the microphone.
Ah, right. Okay. Thank you very much for the clarification. So let me just set the scene again for today. We're going to be looking at the relationship between product design and supply chain and how that might need to change as organizations consider maybe how their businesses need to work differently based on what they've learned from responding to the pandemic. And a lot of what's been discussed so far has been about that immediate response. So, how do we react to the crisis? And then we're currently in this phase of thinking about how do we get people back to work. And where Paul and I want to go today is to look a little bit further ahead based on a look at those experiences and what might those mean once everything is back to whatever people start to call this new normal or business as usual or whatever that might look like as we emerge from lockdown. So we're going to have a look at what that might be, how engineers might be influential in that, and then we'll open that up from discussion and some questions at the end. So just to complete the introduction, let me do a little bit of scene setting. So some of you who were on a webinar Paul and I did about this time last year on product lifecycle and supply chain will have seen this picture before. We're looking at the interrelationship between these two process streams, the product lifecycle, product development to end of life stream in the red, and then the supply chain stream in the brown. So today we're looking in the similar subject area, but very much from this different angle of thinking about our products and processes differently as a result of the impact of the pandemic. And the one thing perhaps that's brought to people's attention in a way it didn't before is how critically important supply chain is. It's almost like the unrecognized discipline. But I'm sure those who've experienced shortages on supermarket shelves or components to make stuff within their organization will have realized how important supply chain is. And if I look at the poll, it looks like most people haven't answered it. I was trying to get a sense of what the balance of people were. For those people who've answered, it looks like the majority are working in product development, a few in manufacturing engineering, very few in supply chain. So it'll be interesting, perhaps, as we sort of start to raise the importance of supply chain in today's conversation, whether those of you in the product development and manufacturing engineering space can explore ways in which you might get more connected with the people in your organization who are working in supply chain. And for the supply chain guys among you, really interesting to think about maybe how you can connect better with engineers, how perhaps you can help them to better recognize some of the challenges and how they might respond to them in the way products are designed or production equipment is designed and so on. So let's spend a few minutes thinking about, just reflecting on the last few weeks, I guess. Most of this will be pretty obvious, but if we think about the evolution of time, it's hard to remember now that even before we experienced lockdown, there were companies that were already noticing disruption of supply from China and other Asian countries in particular as they started to suffer the effects of the virus. And a lot of companies here had stopped production long before lockdown and furlough had started, as they were unable to find alternative sources of supply. Wasn't long before we then got into panic buying and supermarket shelves started emptying and suppliers were not able to keep up with that surge in demand through to the point of consumption. And that led to an awful lot of work to see how we can rapidly increase supply, look for alternative sources, maybe rationalize our range so the whole thing was simpler to manage. And then I guess the other change we've all got used to is the move to home working, and therefore necessity's driven a lot of organizations to work through their resistance to adopting some of these new technologies, find new ways of working, and they're beginning to discover the benefits as well as some of the drawbacks maybe that have been stopping them changing. And I just can't believe it'll ever go back to how it was before. So if nothing else, we'll find ways of working differently. So we've got real rapid increases in production in some areas, particularly critical things like PPE, particularly about all those products and parts and systems that were needed to support the increase in ICU capacity in our hospitals. While at the same time, we've got this rapid decrease in demand for other products leading to factory closures, furloughed staff. So very, very much a mixed bag, you know, and lots of organizations wrestling with how can we use some of the new technologies, new ways of thinking that people are talking about around Industry 4, which Paul's going to expand on in a few minutes, to actually help them navigate through, deal with the impact of that. And I'm really pleased to say that across the nation, engineers rose to that challenge, you know, and here, huge shout out for the teams of engineers and supply chain people and everyone else who really just threw themselves into meeting this demand. We're all familiar enough, I'm sure, with the stories of the rapid developments of various types of ventilators, companies from different industries adapting their production, pretty much anybody with a 3D printer making face masks, and just the heroic efforts of all the teams that came together to create the Nightingale hospitals, really in record time. And to me, these are all great examples of what can really be achieved in way shorter timescales than we would normally see. So that's great use of existing technologies, really highly collaborative, focused ways of working that lowered all the barriers to getting stuff done. You know, and I just wonder how much of that was cutting corners, missing steps out because people were prepared to take a risk, and how much is actually teaching us valuable lessons about stuff that we do in a way today which is actually too slow, too cumbersome, and we could actually start to think about what could be different and possible in, dare I use that phrase again, the new normal. So at this point, I'm going to hand over to Paul to think about where that might take us in the future.
Thank you, Harvey. Of course, whilst it has been and still is a really extreme event that we're facing at the moment, COVID-19 is not the only significant disruption that we faced in recent times in our supply chain. So whether it was the Icelandic ash cloud or the Japanese tsunami, the real question, I guess, for lots of those people who work in supply chain management is what's going to happen next, and are we actually ready for it? Rest assured, that's the only note of negativity that we're going to have from this point onwards, but it is worth reflecting on that. And I guess, of course, all these events are just a reminder of the fact that we are living in what is often termed a VUCA world. So for those of you who haven't heard this term, it was first originated in the 1990s by the US Army to describe the new reality of a world order and the nature of warfare that we all face post the Cold War. It's a world of volatility, of uncertainty, of complexity, and of ambiguity. And I guess more importantly, all of those factors that drive that are quite often outside of our direct control. So I guess for all of us, more than ever, we are feeling what it feels like to live in that kind of VUCA world. But even as we're starting to emerge from the initial pandemic shock, the future still feels uncertain, I guess. So whether right now our focus is very much on coming out of lockdown and getting back to work where we can and wondering what might happen next, and even though for many of us that uncertainty might even include whether or not we've got a job to go back to or a business to go back to, nevertheless, as Harvey alluded to, it sort of feels right now to move some of our thinking forward to that future and to start asking what role can engineers and engineering take in helping to shape it. So the good news is, I guess we are taking quite an optimistic view in many respects. Just as we saw engineers rise to the challenges with ventilators and PPE that Harvey mentioned earlier, we can also see some real opportunities for engineers and those involved in engineering design to think quite differently about some of the challenges the future might throw at us. So to help shape the way our business respond to customers and really to start helping to design the supply chains of the future. So now that we've set the scene, we would like to share with you some of our thoughts on that role. We want to start a discussion really on what we see as opportunities to think very differently about the role of design and its impact on the end-to-end supply chain. In some respects, these are provocations on our part. They're intended to challenge our thinking and your thinking as well. So please, we would love to hear your reactions and your feedback as we go in the chat box. So the first thing to say, and I think again Harvey mentioned this earlier, is that we've taken a very broad perspective on the role of engineers and their impact, not just on the design of products, but also on how that design impacts manufacturing and assembly, how the supply chain that sources materials and components works, and how the supply chain that distributes and supports products through to their end of life operates. So today we want to highlight 3 opportunity areas related to this broad picture: how to impact supply chains, influencing sales and marketing, and engineering and production. Much of the talk in the economic and business world regarding the pandemic has focused on the massive impacts that have been on both the global and local supply chains, as we saw earlier. Already there's an expectation that supply chains not already disrupted will need to be radically redesigned. So we're talking about new suppliers, new locations for production and factories. Shorter supply chains is often mentioned, with a real desire to try and de-risk supply chain management. In part, we were inspired here by the work of Charles Fiennes. The first opportunity we want to highlight is the obvious but often misunderstood fact that the single biggest factor in determining the shape of a supply chain is actually the design of the product itself. The product architecture contains within it the decisions to make versus buy, to use standard components or not, to adopt a modular design approach or not. All of these things are the biggest drivers to how the product's production supply chain will look, and therefore the kind of risk that it will inevitably encompass. We've also been inspired by the work of Professor Alison Mackay, who I think if she is on the call, I'm sure will say hi in the chat box to you all. And if you want to find out more about her work and the work she's carried out at Leeds University, then there is a link included in the slides later on. We are 100% indebted to her and her team for the following example that will try and illustrate this point. So let's take the example of a cycle handlebar. On the face of it, it's a very simple product and a simple set of design choices. What do we outsource? What do we design in-house? What do we manufacture and assemble in-house? In effect, what do we want our suppliers to do? As you can see, even a couple of decisions on what to outsource will impact the resulting shape of the supply chain. In effect, the design of the supply chain is being set potentially very early on in the design process, and often, as we appreciate, quite unconsciously, or at least with a low awareness of how much has already been influenced by product design decisions. At this stage, of course, we can move to decide on which suppliers to use and how many suppliers to engage with. But the reality is the supply chain design is effectively set, and as a result, the nature of some of the risks faced has already been determined. And of course, that was a really, really simple example. When we start to look at more complex products, the potential complexity in supply chains is absolutely mind-blowing. We're used to seeing supply chains modelled as per the first diagram. The second, which is a representation of Airbus's supply chain, is much closer to the reality, and as a result of thousands of such design decisions. In summary, and in the words of Charles Fiennes, make versus buy is not just about whether it's 2 cents cheaper or 2 days faster. So let's explore this area a little bit more. So in addition to the basic product architecture decisions, there's also the need to consider design for sourcing. By that, I mean specifically ensuring that product designs maximize their use of standard, easily available components. Doing this can significantly impact supply chain performance and the supply chain risks faced. The benefits, I think, are well understood, but in the context of the general concerns around the resilience of our global supply chains, they are worth reminding ourselves of. So factors such as more supplier options and the need for less inventory are key to ensuring that our supply chains become more agile and more resilient. And these benefits are not just to the production supply chain, they're also propagated throughout the service supply chain as well. So let's consider an organisation that is also providing a repair service over multiple sites. Here you can start to see the rule of 10 coming into play. This rule or guideline states that the cost to find and repair a defect in a component is approximately 10 times greater at each level of assembly and distribution. This means, for example, that once a product has a such as a mobile phone, is in the hands of a customer, the cost to repair could be at least 1,000 times more than if the same defect was found at initial assembly. The use of standard components can help to reduce both the probability and the impact of this risk. And finally, whilst we're talking about how to impact supply chains, I want to briefly mention the role of technology, and in particular Industry 4.0, as Harvey alluded to earlier. As we heard in that intro, there has been somewhat of a boost to the profile of technology during these initial phases of the crisis, whether we've been talking about additive manufacturing being used to produce PPE, or the use of virtual modelling tools to help with rapid prototyping and design. The awareness of technology as an enabler to all our lives, think about Zoom for example, has been greatly enhanced, and this provides a great opportunity for us to review its use in designing, producing and servicing products in life. So let's think, for example, think about the need to monitor products remotely when it is becoming increasingly difficult for engineers to travel and visit multiple locations. This whole area also provides us with the opportunity to develop new product service offerings based on the capabilities of Industry 4.0. And this leads us nicely onto the next opportunity area, influencing sales and marketing. Over so much of the last few decades, supply chains have been subjected to increasing demand for more individualization, greater responsiveness, and more flexibility. These demands, translated into increasing product variety, have impacted not just the products themselves, but have also resulted in more complex manufacturing operations and more complex supply chains. But very recently, we've seen a bit of a reversal. So we actually ran out of toilet paper. So what actually happened in response to this? Well, from a supply perspective, there was a move to standardize on size and packaging as a way to declutter the supply chain, to free up capacity lost to complexity and speed up response times. Surprisingly, from a demand perspective, we didn't really care. When faced with a shortage, my preference for aloe vera scented branded toilet paper didn't really matter. I bought the standard 1 mega size package and was grateful for it. So will this trend change our economy and buying habits for good? Well, I guess we think not. But the way that this experience has increased the visibility of the true cost of variety and complexity is, we think, still an opportunity. Where we think this opportunity is, and where we think engineers should lead the debate, is on the topic of late configuration, or as some people refer to it, postponement. The idea of this is that we delay or postpone our commitment to a product in its final form for as long as possible. Hopefully this illustration gives you an idea of how this could work out. The horizontal axis follows the timeline of assembly, and the vertical axis indicates a number of different variations we are considering. In this example, the components and sub-assemblies unique to a particular product variant are already quite early in the process, so we are committed to the particular order or variant very early on. The result of this is that we will have less flexibility and more inventory in the system to allow us to meet customer orders, probably a more complicated bill of materials to be managed, and so on and so on. In this second example, the design has enabled us to add those items that are unique to a particular variant much later in the assembly process. This means that we are not committing the product to a particular customer order or variant until much later in the process. In the early stages, we are using standard components or components that are common to all variants. This can allow us to start the manufacture and assembly process and allow it to progress for some time before we make that final decision. This will hopefully, inevitably, reduce inventory, allow us to reduce the time from order placement to delivery, or indeed both. Of course, this is much easier said than done, and a lot of work has to be carried out early in the design process to allow this approach to work well. So enough of me now. I'm going to hand back to Harvey, who's going to talk you through the third opportunity area, design for manufacturing and assembly. You should have the ball now.
Thanks, Paul. I do indeed. So when we think about manufacturing and assembly of products, I guess the pandemic's highlighted two key areas that we need to pay attention to. One is around how quickly we can respond to a sudden change in the situation, which might lead us to think about how we can reduce lead times both for product development and production to generate a greater level of responsiveness. And the other one's about how easy it is to change what we make. Now, whether that's an increase or decrease in volume, whether it's a change in the mix of products we make, whether it's about making different products altogether. So how do we consider the design of both our products and our production facilities to get us greater flexibility? And becoming better at these aspects definitely requires some additional thought. But in my view, not all of them come with additional cost if you consider them at the right time and in the right way. And indeed, it can even be possible to save money where you do this really well. So if we think about a really simple product supply chain that has everything in it. Customer has an expected lead time, and we can manage to do any necessary design work, planning work, source all the parts, manufacture and assemble the product, deliver it to the customer, all in a shorter time than the customer's expecting in terms of his required date. Life's easy. So the first question is really, is it possible to organize our business that we can do that? For some businesses, absolutely yes. Probably for a great number more, the answer is no. And typically, we get a situation that is like this. We want a much shorter lead time. And if we look at the time it takes us to do all of those activities, it's much longer than our customer market's expecting. So that means we have to make decisions on what to design, what to buy, what to make, what to put together. We're going to have to do that before we know what the true customer demand is. So we've got to have some sort of forecast, some sort of set of assumptions that will enable us to do that with a degree of confidence. Otherwise, we can end up designing the wrong product. We've got too many of the wrong parts, which means we end up with warehouses full of inventory of either the wrong stuff or finished goods that people don't want, which all has a cost and an obsolescence risk, as well as the possibility that we've all experienced that we can't actually provide customers with the things they really do want. Now, I can imagine a number of the engineers out there going, well, surely that's procurement's problem, or it's manufacturing's problem, or it's sales's problem. What's that going to do with us, particularly if we work in product design and development? And certainly with an awful lot of organizations we work with, those are some of the comments that come through. And I can imagine at least one of our current clients chuckling away in the background as I say that. And of course, at one level, these clearly are topics that those functions need to deal with. But at another, they affect the success of the whole organization. And it's really important for those of us involved in the engineering, the product development arena to understand the impact of some of the decisions we make or that are made earlier on in that design process. And my challenge to a lot of organizations is like this. What if we could be clever and actually decouple a lot of that design, sourcing activity, manufacture and subassembly activity so that it's to a large extent independent of the customer lead time, so it's external to the order cycle, and then we're able to do any necessary specific activity related to an order within the lead time. That means we can manage those customer specific requirements much more easily through the application of really good supply chain principles. Great example of that's a Formula One pit stop. What happens in the 1.5 seconds is actually a result of some really clever thinking and some great design and great preparation of the pit stop team before the car appears in the pit stop bay. And another great example in supply chain, if I look back, it's probably not so relevant today, but one of the great examples in the laptop personal computer industry, 15, 20 years ago when I was starting in consulting, was somebody like Dell, because they'd got all the right parts, they'd got an idea what customers want, but they didn't actually start to do the detailed specification and assembly of a customer's computer until the order was received, and they were really, really good at it. And that was a great example of late configuration that Paul talked about a minute or two ago. Another area we can look at is the example of parts machining, and how we can build maybe more flexible arrangements into our factories rather than having dedicated machines or groups of machines for each product. I mean, for low volume type manufacture, we might have much more flexible CNC machining centers, or we might look at alternative technologies like 3D printing, additive manufacturing. For higher volumes that require a lot of complex machining, but we want the efficiency associated maybe with a more dedicated machine type, we might consider some sort of flexible manufacturing system. At its simplest, it would be a multi-station machining line where all the parts went down the line, but not all of them had work done on them at every station. So that would give us ultimate flexibility. Moving up the scale, we could maybe have a more flexible manufacturing system, as we show here, with all the different possible steps, with multiple machines at each step, and planning a different route through those machines for different products. Again, a lot of flexibility, as long as we're careful to avoid introducing capacity limitations, because too many components need to go through one particular machine in the middle of that cell that might cause us a bottleneck. So some real careful consideration both for the design of the product and for the machining center to allow us to do that. In a similar way, we can move on into assembly, and I'll highlight a couple of approaches. One is one that we were just starting to work on in BMW when I left, and has now seen its fulfillment in BMW Group factories around the world, which was the idea of having a common assembly sequence for everything from a Mini to a Rolls-Royce, and laying out every factory around BMW Group with the degree of flexibility that, at least hypothetically, would allow you to build any vehicle in any factory. Now, obviously, there are lots of practical reasons why we don't, and certain factories build certain things. Oxford builds Mini, whatever. But actually, in principle, it's a great idea, with the one downside that it can become a big deal to change that standard sequence. So it's a pretty long-term decision and investment. But on the plus, it means engineers can standardize and optimize every aspect of the design of their vehicles to build to individual customer requirements in a highly cost-effective way and at the standard required. Another option might be to design into the factory the ability to reconfigure the layout of equipment really quickly to accommodate a switch from one type to another. And that could be hour by hour, day by day, or in response to a big change like COVID-19, where we need to respond to a complete change in what we have to make. And that's something that organizations like Toyota and others are real masters of. So let's just think now then, having considered what those opportunities are and some of the principles, we as engineers have an opportunity to influence how things adapt and evolve going forward, equipped with that knowledge. But maybe it requires us to change our thinking a little bit, as in this great quote from Einstein, you know, to solve new problems, we have to change our thinking. And to get us into that, I'm going to start with this picture. Now, anybody who's worked with me before in this audience will have seen this picture. And I'm not going to apologize for showing it again, because I think it's such a key indicator of one of the fundamental points that is often missed by less experienced engineers and others. And that's that the biggest opportunity to influence all of these different aspects of a product is while the design is still very fluid. The more sets of requirements, the more aspects of the total system that we consider and resolve at this early stage, the easier it is to meet that wide range of requirements and achieve the levels of flexibility and responsiveness we might aspire to in the future. And of course, conversely, the further down the route we go, the more difficult, costly and time-consuming changes are. So if we think for a minute, these are just a few examples of this wide range of requirements that various different stakeholders might place on a new product. How do we create the design? How do we create the production process? How do we create the supply chain that then meets all of these different requirements? And it's obvious that in pretty much every case, there's no one right answer. Which of those requirements gets greater prominence or less prominence in the final design of the product, the production process, the supply chain solution, depends on a whole range of factors. Do we want it to be lowest cost? Do we want the highest quality? Do we want the greatest flexibility? Do we want the fastest delivery times? Do we want the product to be easy to maintain? And I guess one of the ideas Paul and I have been chewing around as we have put this material together is how much do those things change as a result of thinking about the implications of our experiences over the last couple of months? Because a lot of those requirements can be in conflict. To optimize one means you have to be less capable in another. For instance, one example we see a lot is sourcing to low-cost countries was a great way of reducing cost, but it results in long, relatively sluggish, relatively inflexible lines of supply that we might start to think are no longer appropriate in this world, and therefore we need to think about some of those challenges. At one level, the whole debate at a national level at the moment is about what's the trade-off, what's the balance we look for between keeping people safe and getting the economy back to work. And those are really challenging type conversations to have. If I go back to Paul's illustration from earlier and add a little bit more detail about it, a lot of those decisions we make actually are going to have implications as to our organization's competitive strategy in the marketplace, and the limitations of some of the previous assumptions we've made are really become highlighted. So this isn't a new thing in a way. That the theory around this has been around probably since the 1990s. The Charles Fine book that Paul referenced earlier was written in the late 1990s as a result of all the study of Japanese manufacturers and others done in the US. So we think about the relationship between product architecture and supply chain is about late configuration, interchangeability of parts, incorporating new technology. Links between design and production are about aligning the product with the equipment that we have to operate it, and how flexible or not that needs to be. And if we look at the pairs of relationships here, we've got technology, which is around aligning product and process. Architecture is about the relationship between the overall design and how the supply chain is constructed. And on the fulfillment stuff, it's about the way in which the logistics system and the production system link together. And to do a really good job of designing a product to meet that real market need, we need to think about those connections and relationships well in relation to where the organization is trying to be. Which of course goes without saying. I think that to deal with that requires us to work really collaboratively. It requires us to manage some of these trade-offs between different sets of requirements. And we think engineers have got a real opportunity to lead the discussion. One of my great case studies I use on the new product introduction course is around the role that chief engineers fulfill in companies like Toyota. Engineers with that sort of knowledge, with that sort of understanding, are great at coordinating all these different functional requirements. And I think there's a real call for us in the UK to step up into those roles. Now, of course, resolving all these different sets of requirements is not actually always as straightforward as it seems. I mean, have you ever had the experience that trying to talk to someone from a very different functional area is like they're on a different planet? One of the things I've learned to appreciate over the last few years as I've worked more with Paul and others is both the value and the difficulty of looking at other people's perspectives. Too often we interpret what other people say through the lens of our own thinking and our own perspective. And if you're not sure what I'm getting at there, let me just try and illustrate that for a moment. I'm going to really briefly show you a picture. And I want you to type into the chat box what you see. Here we go. I'm only going to put it up for 5 seconds. So have a look, quick as you can, type in the chat box, what do you see? Okay, there we go. So we get quite a few different reactions. If I look at the majority, there's a few outliers, but we get some people are seeing a guy, most often playing a saxophone. Some people are seeing a woman's face. Some people are actually seeing both. Somebody's just seen the Statue of Liberty. We can have a conversation about that at the end. I'd love to see where that came from, but it's really interesting, isn't it? We see one thing, actually we get very different views about what this is. And for those of you that were struggling to see one or the other, let me just show you. So there's the picture I showed you. For those who want to see it, that is the saxophone player. And that's another illustration that might help you to see where the woman's face was for those who didn't get it. Yeah, and that's the picture I showed you at the beginning. So what that illustrates, I think, is sometimes it can be really hard to get to grips with another person's viewpoint because we're so preconditioned by our own ways of thinking. And I wonder sometimes, once that happens, how do we tackle that situation? And maybe what are different ways we might go about it. I suspect a lot of you will have seen the picture on this slide. And, you know, you ask, who's right? You know, who's right in that case? Again, interested in what you think, but in the end, does it matter? Because you could say either neither of them is, or they both are. And when we get a difference of view like that, what's the productive thing to do? It's not about arguing for why you're right and the other person's wrong, in my view. What's really helpful is to understand what's driving that other person's perspective. Yep. Might be the way they see the world. It might be something about their particular set of requirements. It might be what they believe the priorities need to be, and so on and so on. And perhaps the most useful thing we can do is really work hard to understand where they are coming from, and then to make sure that they understand us. Because at the end of the day, the goal is for the business is actually to identify the design solution that best meets the requirements from all those different perspectives. Another useful idea that I introduce on the Design for Manufacture course is this idea of trade-off curves. So in this particular example, we're looking at the trade-off between cost of assembly and cost of manufacture. Because a design for manufacture focus might lead us to look at components that are really easy to make. But almost inevitably, that drives us to having a lot of smaller, easy to manufacture components, which means there are more bits put together, which means the assembly cost goes up. At the other extreme, if we're looking at design for assembly exclusively, we focus on having bigger, complex parts that all the complexity, all the difficulties in the machining and the manufacturing, and actually we have a relatively small number of things put together. And somewhere, if we're looking to find balance and manage that trade-off, there will be an optimum total cost somewhere in between the two. And so the idea of trade-off becomes quite helpful. So again, any thoughts you have? What are some of the trade-offs that you can think of? Type them in the chat box, and then I'll share another couple of examples of ways we can look at that. What are some of the trade-offs that you guys deal with or can think of? So cost against weight, for sure. I'll talk about that one in a minute. Anybody got any others? Off-the-shelf parts versus protecting IP. That's a really interesting one, isn't it? Yeah. lead time, time against cost, modular versus stick to built, cost against quality, cost against throughput, strengths to weight, cost and benefits, supply against it. Yeah, loads of them, aren't there? You see? You know, and there's a question there about, does cost always become the big player? You know, and one of the lines of thinking that I always find helpful when we're looking at the total product life cycle can be, how can we relate everything back to the lifetime cost of that product? That's quite a good leveler for reconciling and looking at what's an optimum decision. You know, because we can easily apply that sort of trade-off approach to material cost against process cost. You know, sometimes we might go for a cheap material that is really difficult to machine, or we might go for a really expensive material, or a more expensive material that is actually much easier to machine. And again, there are extremes, and we can pick an optimum in the middle. We might pick a point like this, which says, you know, Paul was talking about numbers of different variations of product, you know, and some of those low volume variations with extra features in actually might cost us quite a bit when we look at the total cost of providing them, but actually generate relatively little extra revenue. So again, you can start to think about where's the most profitable position to be within the marketplace. And somebody mentioned design cost against weight earlier, and that reminds me of another great story around this, because, you know, drawing out those trade-off curves can be quite time consuming. And so there are ways in which we can actually think about converting some of that analysis into simple rules of thumb. And one of the things Boeing did way back when they were developing the Boeing 777 that became a sort of standard that other players in the industry copied was, let's get a trade-off that says, for every pound, if they were American, kilogram if they were Airbus, you know, for every pound or kilo we can reduce the weight of the aircraft, it's worth putting X amount of pounds or dollars on the cost of the aircraft, on the development cost of the aircraft, because the airlines will recover that with reduced fuel consumption over the life of the aircraft. So they gave the engineers a really simple rule they could apply. If they could apply that rule to the thing they were designing on, they knew they were going to make a really good decision that reduced the cost and didn't take loads of time. Brilliant. Final point really is about the importance of involving everybody up front and early. You know, again, the learning for that at one level feels really obvious if we remember back to the shadow picture, and is absolutely reinforced by looking at the way some of the best practice companies like Toyota and others do. So, you know, that's it. Final point. I think one of my guys I was chatting to before this said collaboration in the end is how we get this stuff to work better. You know, and that's not just about engineering, is it? There are lots of people in the past who have really looked at the benefits of collaboration. In the end, you know, a lot of Darwin's thinking was around collaboration and so on. So there we go. Hopefully that's given you a few things to think about. You know, I haven't managed to follow all the things that have been going on in the chat as well, but Andy will bring us back to those in a few minutes when we come to some Q&A. But I actually just wanted to get a bit of reaction to some of the stuff that we've shared today. So I've got 3 questions there for you to say, you know, what have been some of your key wake-up moments for this session? You know, what's sort of been new to you, or something that you thought, I've got to think about that in a different way? What might be some of the top challenges for your organization as we come out of lockdown and back into some sort of normality? And also of the sort of topics we've shared about, which are ones that would be really relevant or useful for you guys to learn more about, and we can look at putting on future webinars or building into our training offerings some more sessions on those topics. So please, anything on that in the webinar. If you've got any particular questions, please pop those in as well. And in a minute or two, I'm gonna hand back to Andy to moderate answering any of the questions anybody. So yeah, really interesting thing. You know, somebody said part machine, parts and additive manufacturing. Real interesting trade-offs there, aren't there? That we've seen quick response additive manufacturing, even if it's been high cost, but no tooling involved. My IMechE colleague Matthew Laskay runs a great session on the benefits of additive manufacturing that you can tap into. I think there was a webinar on that a little while ago, and he does run a course on that as well. Yeah, a lot of stuff about rethinking our outsourcing choices. Paul, if you want to chip in on any of these, please do. Or Andy, come to that. We can sort of just see what some of the things are that are coming up that sort of have attention. Yeah, I mean, as you say, long product development cycles make it really hard to respond. Yeah, but there's a bit to me that says, doesn't that make it all the more important to start thinking about this stuff? And within that long cycle, how can you start to think about creative ways you can build that flexibility, that responsiveness in, because you're stuck there with a product that's actually going to be around for quite a while. Yeah, some stuff there about maybe the balance of which function gets the loudest voice, maybe doesn't work as well as it might have done. Oh, there's an interesting one. Why Chinese companies have been investing in the UK. That's really interesting, isn't it? Because one of the things I know about the Chinese is that they're really good at taking a long-term view about looking at various options. And if people start reshoring stuff from China, because it was starting to happen anyway, they're going, yeah, but we've now got a UK subsidiary, so we can actually respond well to that.
Harvey, I think what is also really interesting in the comments that are coming through is that the common theme is if you took everyone as a question, none of them could be answered just by an engineer or a designer. They would all require input from other parts of the organization to different degrees.
Wow, that's really good observation, Paul. Absolutely. Doesn't it just underline the importance of that upfront collaboration, everything else? Yeah. And one of the interesting things, and it's a plus and a minus. You know, Alan just said, I can work effectively from home. You know, we've learned how much easier, how much more productive, how much more effective it can be to engage with groups of people all over the place while sitting at our desk at home or perched on the edge of the bed, depending on what your home workspace currently looks like. Yeah. Another one from Douglas. Yeah. One of the standard comments when I run a training course or a workshop is we've never got time to do any of this upfront stuff. And Douglas is going, well, I don't have to drive to work every day, so I don't know what your commute was like, Douglas, but for my wife, she's saying I've got 2 hours back every day. And perhaps that gives us the time to start to have some of these better conversations. Yeah. Nice one, you know, from Ilidio that says, you know, customer satisfaction, buying more choice. You know, as Paul mentioned earlier, isn't it? One of the things that happened as a result of responding to the pandemic was reduction in choice, but we didn't mind because something was better than nothing. But as soon as supply frees up again, how much is that individualization, that choice, going to come up? Douglas, I meant your commute before lockdown, not now. Anyway, great. Some lovely comments. Brilliant. So let me just say, in answer to a couple of questions that came through, we were asked about references for the books. When you get the slides through the LMS, and if you follow the chat, Charlotte's sort of let you know that a recording of the webinar and the slides will be available shortly. If you've registered for the session, those are some of the books that we were referring to. and Paul referred to Alison Mackay's work up at Leeds, and there's a link through to Alison's team's website there as well, where you'll find a lot of extra resources. There you are. Charlotte's just popped the registration details for the learning management system in the chat as well, and you can get access to all the webinars and other stuff through there. The other thing we've been working on is how we can offer some of our existing product lifecycle courses virtually. So we've done a little bit of restructuring and redesign to make that very modular. And a lot of the core stuff is common to all of the courses. We've then got these modules. At the moment, we've effectively reconstructed the public courses, but there's definitely an opportunity, having moved stuff online, to bring in new modules around design for sourcing, design for service, other stuff that's really interesting, but probably wouldn't warrant a one-day's course on its own without duplicating a lot of the stuff that's already there. So those are coming up. We've got some initial dates in the calendar for those as online courses that you can sign up for. And if those dates don't work for you, please do let us know, and we can look at alternative dates if there's enough demand for those, either as public courses or as an in-company offering. So I'm going to hand back to Andy now to moderate a discussion on any questions that come up. So if you've got any questions you'd like Paul or I to comment on, or even to get comments from the rest of the audience. Amazingly, we've still got nearly 340 people on here. So we've got lots of opportunity now in the last few minutes to deal with any questions.
Thank you, Harvey. And it really is the last few minutes. All that great interaction in terms of chat has taken up some of the questioning time.
Sure.
But let's just have a quick look at some of the questions that have come in. Harvey, if you could pass me the ball as well, that would be great.
Sorry, Andy. Yep, I will do.
Question from James. Who is responsible for ensuring certification is included with deliveries of stores? And would this be considered quality assurance, procurement, or logistics responsibility? That seems like one for Paul to me.
Yeah, thanks, Andy, and thanks, James. I guess just a reflection first. It's interesting when we open up the debate around the end-to-end supply chain and the role of designers. Of course, it does start us to think about the end-to-end supply chain and what that entails. And I think I mentioned in my intro, a lot of the work I do is about getting operating models right and organizations right to work more effectively in an end-to-end and collaborative way. And back to the question, it's interesting that questions around roles and responsibilities and accountability is one of the most important things to get right. So I'm going to answer it in one way very simplistically, and then maybe try and provide a little bit more flesh on the answer. The first and simplistic answer is, to a degree, it often doesn't matter who's responsible. What does matter is that responsibility is clearly articulated and understood by all those who are involved in the process. That's, I guess, the guiding principle you need for an effective organization. But I guess more practically related to this question around QA, I guess the answer really is that in terms of responsibility to carry out the activity, then typically it's going to be your logistics teams that are going to be involved in providing resource to do that. So carrying out the activity it will be whoever's best placed to do that, and that could in some cases be somebody in store as well, depending on the nature of the supply chain. The more interesting question is understanding the accountability for the outcome of that check or QA test. So who is responsible for ensuring quality in the supply chain, either from an operational or from a supplier management perspective? And again, it probably doesn't matter who in the organization is, but it does really matter that everybody understands who that person is or who that team is and what that responsibility and accountability actually means. Hopefully that helps.
Very good. Thank you, Paul. Thanks for that answer. Just looking at the time, we really are up against it a little bit. So I'm just going to wrap up. And so that any of you that do have to rush off at 1:30 exactly can do that. We just want to draw your attention to some upcoming training programs before we sign off. There's some virtual sessions, as well as we are beginning to run face-to-face sessions again now in Sheffield, not yet in London, as you can see. And there are also some upcoming webinars. Do keep your eye on the website for more information. That's changing more quickly than it has done in the past, because we are trying to deliver a little bit more content in terms of webinars, given the current situation. But one coming up at the end of July on metals technology, as you can see from the slide. Final thank you to Harvey and Paul. Details on the screen if you want to get in touch with them. Great to hear your ideas and thoughts on these topics and how things are changing in the current world. Much appreciate everybody's input and comments in the chat box and participation. Hope to see you on our webinars again in the future. Thank you very much for attending.
Thanks from us too. And I would say, absolutely seriously, if you've got any question on this that we haven't had time to answer, please do pop it in the chat before you drop out, or ping an email to Paul or I on the email addresses that are on the screen.
Yeah, absolutely. Concur with that. Thank you all.
Thanks, everybody.